Now, moving to network protocol functions, devices use agreed upon protocols to communicate. Protocols have one or many functions. I think this we can relate to the network types that we just discussed. We have protocols which have a function of addressing, identifying the sender and receiver. Example, IP, version 4 and version 6. All right, that's the function of addressing protocols. We have those which provides guaranteed delivery. The best example, TCP, guaranteed delivery. There is acknowledgement yekuti message yasvika here. Pakasayipinda acknowledgement, it means the message yainausvika, we resend until message yadeliverwa, providing guaranteed delivery. It might take some time. We'll get the difference between TCP and UDP. TCP might take some time. It's very slow, in a lot of overhead because of that, but it's very reliable in the sense that message could yasvika at some point. With UDP, you will not have that. Right, flow control ensures data flows at an efficient rate. We've gone through that. We have protocols which have a function of sequencing. I've already defined sequencing. Uniquely labels each transmitted segment of a data. Very important. We have protocols which are responsible for error detection, determines if data became uncorrupted during transmission. Protocols responsible for application interface, process-to-process communication between network applications. We look at all the protocols, most of the protocols, most common protocols, and what will be their functions. All right, let's move. Protocol interaction. Network requires the use of several protocols. Each protocol has its own function and format. So here we have, I think, one of the best examples that we can have to explain protocol interaction, how different protocols from different layers. Okay, we've not got to define layers yet, but let's just say how different protocols interact. And in this example, we're going to look at a device sending a web request to a web server. So this is, can I write something? Right. So this is a client. All right. This is a web server Google. So this is your Google server, right? So if this client wants to Google something, we call it requesting for information, all right? Client server model, one requests, one gives the information. That's the server, client server. Don't forget that. So if a device sends a request to a web server for its web page, there are several protocols which interact together so that we get that information from the web server. One of the protocols, Zinotanga, we have HTTP. And HTTP governs the way a web server and a web client interact, defining content and format. In summary, HTTP defines rules for how those requests and responses are formatted and exchanged. Mapicture mabudira web page zvaunenge wakatarisa, the format web page, it is defined by my rules a HTTP. So one of the first protocols that you interact is HTTP because you're dealing with my web pages. Then from that, you also interact with the TCP protocol, which is responsible for establishing a connection between the client and the server. Before even transmission starts, there is need for establishing a connection between your client, you as a client, and the web server, so that there is a link between those two devices. And the TCP protocol is responsible for that. If there is a link, it means that I send the information, that I receive a back acknowledgements, knowing good information area, etc., etc. So from HTTP, yapedza, we have TCP playing his role. Then we have IP also playing a role, identifying kuti client ndiani, kuti server ndiani. Kana request something from the server, you need to know the IP address, for example, of the server, so that you can request per location iri correct. Server kana rakuresponda, it will need an IP address ya client, which is the source of the information, so that kana rakuresponda rinoresponda to the correct recipient, in this case kana web server rakuresponda. So what defines that is the internet protocol, delivering messages globally from the sender to the receiver. Then from there, we have another protocol, Ethernet, which delivers messages from one NIC to another NIC on the same Ethernet local area network. So, maziva kuti sender na receiver ndiani, you need to send a message to the specific device. Inosvika sei pa specific device ipapo. Most probably use the Ethernet line. Ichasvika LAN via the Ethernet cable, yozosvika pa PC. The rules which are responsible for communication in Ethernet LAN is the protocol Ethernet. So you see my protocols, they interact with each other, sort of hand over. You need a page then you hand over to another layer, another protocol takes over, you hand over to another layer, another protocol takes over until we have communication. Protocols, they don't work on their own. You then have one rule, Shandarega. No, we have a number of rules which will govern how we communicate. So I think this is a perfect example of how protocols interact so that we can communicate. Right. Now moving to protocol suites. By definition, what is a protocol suite? A group of interrelated protocols necessary to perform a communication function. So if we have a group of related protocols, we call those a suite. And one of the examples, dzema suites dzatinadzo, suite, dzema suite, English, I think it's suite, pronunciation. Right, one of the examples dzatinadzo, we have the TCP IP. We'll look at that. Then we have the OSI. We'll look at that as well. Right? Protocols must be able to work with other protocols. The protocols are viewed in the terms of layers, higher layers, lower layers, concerned with moving data and providing services to the upper layers. So my protocol suites is who look at them. They are made of my layers, which we can separate, saying these are the higher layers, these are the lower layers. Examples in my protocol suites, like I was saying, with TCP IP, the Internet Protocol Suite. Then we have the Open Systems Interconnection, OSI. Those two are the ones who will be focusing on CCNA. AppleTalk, Novell Network, no, not Cisco. But they are also protocol suites, a group of related protocols. Right. And per my layers, as you can see, for the TCP IP, my layers, we have the application, transport, internet, network access. So we have a group of protocols which form a layer at the application layer. Some of them, and one up, HTTP, DNS, DHCP, FTP. It is very important at this early stage to be able to identify a protocol, its function, and the layer it belongs to. I can say the easiest ones, DNS, its function, domain name translation from domain name to IP address, that translation, or vice versa, that is the function at DNS. Layer, it belongs in the application layer. At this early stage, you need to be able to identify a protocol, its function, in the layer it belongs to. It's very important. In the transport layer, we have mainly these two, TCP and UDP. In the internet, IPv4, IPv6. We also have ICMP. Ping ndo painobva ICMP. Yatinoti ping, tikati protocol. Ping is a protocol. The protocol behind ping is ICMP. So lastly, we have the network access. I think the most common, these two are very common. Even the ARP, we'll discuss that one. But Ethernet for local area networks, very common. Then we have wireless LAN. This one defines Wi-Fi, the wireless LAN protocol. All right, so this is it for my protocol suites. We'll look at the TCP/IP protocol suites. I've already touched on that one. Used by the internet and includes many protocols. An open standard protocol suite, freely available, standard-based protocol suite that is endorsed by the networking industry. So that is I think that's the most common. That one and the OSI, the most common that we are going to be used. The difference being this one is more practically applicable. This one, the TCP/IP, is more practically applicable. I'll explain in later slides. The other one, more theory. It's a theory-based suite/model. So as you can see, per TCP, we have layers, 4 layers: application, transport, internet, network access. Like I was saying before, ASMR protocols are the most common ones. At least you need to know where they belong. DNS, you definitely need to know who will deal with that. DHCP, DHCP, Slake, I might forgive you. SMTP, no, you need to know that one. FTP, you need to know that one. HTTP, even HTTPS, you need to know that one. The rest, we might forgive each other at this level. TCP, UDP, no excuses. IP, NAT, ICMP, OSPF, those ones, you definitely need to know my protocols because you will encounter them very frequently. ARP, Ethernet, wireless LAN, we encounter those as well. So these are some of the most common protocols that we have. You need to know what is their function, which layer do they belong to. All right, an example, TCP/IP protocol example. I think this one, we've already gone through this one when we explained if we want to communicate with a server, with a web server via a web page. At the application layer, now we are involving the layers now. At the application layer, which is responsible for interfacing with the user. You as a user, you always interact with this layer. That's one. You as a user, you always interact with the application layer. Izvezvi ndakatarisa screen rangu, I'm typing, I'm writing on a board kandinako, I'm moving my mouse, I'm typing whatever I'm doing for computer yangu. All those interactions, they are interactions with the application layer. So the user interacts with the application layer. And that interaction will be interacting through Dynamo web pages with a protocol called HTTP. Then HTTP kana yapedza basa takupinda mune rimwe layer. Topinda transport TCP yosunuzira. Yapedza topinda mune rimwe layer. The IP protocol yoita addressing. Yopinda mune rimwe layer. The Ethernet yoita format our message so that we can transmit it over a link. So Patia's explain things like encapsulation, de-encapsulation. This is basically what will be happening. Data remove varodai. So rutangira panapa, tichitangira pa application. Parinozosvika panapa rakubuda kuti riende uko raku network access. Robuda roenda rosvika kunoko. Parinosvika panapa rinotangira kusvikira ku network access, rotanga kukwidza kudai. Ropinda mu-internet, ropinda mu-transport, ropinda mu-application. Web server, kana kuna user ari web server, ndiye anenge akuinteracta neinformation at the application layer. Apedza oresponda. Panoresponda message yakuda kudzoka kunoku inotangira futi kuapplication layer yotanga kudzika dzamira yasvika kunetwork access. Painosvika kunetwork access, it means yapanapo yakuda kuenda uku yobva yatransmitwa yosvika kunoku, totangira futi kuzasi network access yotanga kukwira futi up until we get to the application. That's where you see page rangwa Google kuti rakaita sei after the response from the web server. So that is how protocols interact. Right. A communication process. I think we explain as slides, but let's go. A web server encapsulating and sending a web page to a client. Then we have decapsulation. Definition, encapsulation. We've already defined that. Adding a message to another message. Adding a header, a trailer to a message. More technical. Adding a header and a trailer to a message. So, tichitangira kunoku, because ndokuri kusendwa information. This side, client to do request something from the web server. So chatinotanga nacho, green arrow ndo data ready. No, green arrow that's tutangira kupa. Data ready iri, red blue. Is it vice versa? Just a minute, let me figure this out. Data, TCP, UDP, Ethernet, Oscar Fiscal. Okay, they didn't explain everything here, but let's start explaining everything ourselves. So, can I say the information? Chandinotanga nacho is the data, the message that I want to send. In this case, the message is a request. You're going to do Google or something. I want to request a web server, a web page from a web server. All right. I want www.google.com. I want that web page. I want a response and not respond the information and google.com. That's the message. That message, application. Let's put application. Let's have transport. Let's have internet. Then let's have network access. Those are my layers TCP IP. Right. Data redu interact in the application layer. We have our data. Information yedu. Painodzika kupinda mune rimwe layer transport. A process of encapsulation takes place. Meaning data ready rinoederwa a header and a trailer. So now we have a header and a trailer. Data ready repakati. Right? That is encapsulation. Muheader and trailer domine information about the transport layer. Domine information about when you're talking of TCP, particle segmentation, message has been broken down, particle sequencing, how the message has been broken down, how sequencing has been done. We'll look at my ports. What are the source ports? What are the destination ports? Information in the header and the trailer. Then information is to the internet layer. Then this painosvika internet layer inenge yakutorwa sedata. Internet layer yoedherawo zvayo. Internet layer yoedherawo header netrailer. So in rem transport, if I can say, so header and trailer rem transport. Then we have header and trailer rem internet. Right? Parinodzika kupinda network. Header and trailer network access. This is network access. Header and trailer network access. Then this information ESA so convert into my bits encoding. Encode converted into my bits, converted into a voltage, light, or electromagnetic waves. Then it can then be transmitted. You transmit youya kunoku yosvika kusevha redu. Yasvika kusevha, mabits aya anotorwa akutanga kuita process yedeencapsulation now. Deencapsulation, removing maheaders. So takutanga kubvisa maheaders. Header iri robviswa iri. Mainly, it's very easy explaining use the OSI module. Header parinobviswa munenge mune information, for example, yemaMAC addresses. Information yedu yabva kupi? Ndo munenge mune information header rekutanga. Header rechi2 robva rabviswa, totarisa kuti mune chii? Ndo munenge mune the IP address, the source and the destination IP address. If those addresses match the device yasenderwa, it means the information was destined for that device. Therefore, we can continue to vhura maheader transport layer. Patinovhura maheader transport layer, toona sequencing kuti message yedu, if it was broken down, sequencing yakamira sei. Then kana tabvisa maheader ese, what is left? Data redu. Then data redu rosvika kumusoro kuno riri muweb server. Roprocesswa. Raprocesswa, data redu riri kuti I need a response yeGoogle page. Then response yakuya yeGoogle page yacho inotanga futi maprocess encapsulation. Yotanga kuedherawo maheader ayo. Yosvika apa yochinjwa kuita mabits, yosendwa yodzokera ari mabits. Yasvika apa, process deencapsulation again takes place. Maheader aya akutanga kubviswa futi. So that is how communication in a network works. Encapsulation, adding of headers, deencapsulation, removing of those headers. Encapsulation and deencapsulation, understanding process here is very important in you understanding how communication occurs. And the best way to do that is giving yourself an example. Your practical application. Send a message per WhatsApp. Do that research. Send a message per WhatsApp. What is the protocol rautanga interact now? Rim layer rip. Parinodzika pamalayer. Malayers edu TCP IP OSI not top down. My message, that's how they are sent from the top, from the application. So when send a message in WhatsApp, my application layer, what is the protocol and interact now? Kana dzika yapinda mune rimwe layer, what protocol takes over? Inenge ine function iyi. Ichidzika, there's another protocol that takes over. What is that function? Kusvika wasvika pamabits apo, wakuleya repasi rekutanga, poitwa encoding, message yoenda, otanga kukwira futi. Receive a message, otanga kukwira futi from the bottom layer kukwira kumusoro up until you get to the application layer. That is very important. Give yourselves practical examples dzamunokwanisa kushandisa to understand what is exactly happening with the process of encapsulation and deencapsulation. All right. Now looking at what's the title for this one? Standard organizations. Like I said at the beginning, protocols are rules. But my rules actually, who defines them? Anobva kupi? Who defines that this is the rule that we're going to be using? We have my standard organizations which are responsible for that. In some of them, do our screen paid up. As an engineer, I'm very familiar with IEEE. I'm very familiar with ITU. I'm very familiar with TIA. As an engineer, I'm very familiar with those. All right, IEEE, ITU, TIA. As a student, you need to be familiar with all of them. And what is their function? As a standard, as an organization, what is their function? What are the standards that organization is responsible for? IEEE, for example, ndikatanga kutaura nezve-Wi-Fi, I think of IEEE 802.11. That's a standard. That is the standard that defines Yamunoti Wi-Fi. If I can say it, you no longer need to be saying Wi-Fi. Kuno standard IEEE 802.11. My Wi-Fi akasiyana. We have A, B, G, N, AX, AC, akawanda. That's how you learn. My standards. Who is responsible for that? An organization called IEEE. Ma-standards ekuziva kuti, for example, we have ma-frequencies atinoshandisa for communication. Communication, there are frequencies dzinoshandiswa. For example, Star FM inoshandisa, is it 89 point something, 89.7? I think Power FM ine 93.0, I don't know. Ma-frequencies, kana uchituna radio, there are frequencies which are used by radio. Akati Star FM inoshandisa 89.7 ndiani for a start. There are organizations which are responsible for that, which allocates kuti frequency E haifana kumboshanda, it is reserved. Ukaoneka uchishandisa frequency iyoyo, we have there are repercussions for that. There are organizations which are responsible for that. And some of our organizations actually, like I said, ndo ari pascreen pera. Open standards. What is an open standard? Open standards are basically specifications for products, services, or systems that are publicly available. Open source, publicly available. Open standard, publicly available. Non-proprietary, it belongs to no one. And they're typically developed and maintained by standard organizations. So we have my open standards maintained by my organizations. Why do we have my open standards? In networking, if I can be more specific. Number one, we have a thing called interoperability. Interoperability, basically, I'm trying to find an example. Okay, let's define it. It ensures interoperability. It ensures that devices and softwares from different manufacturers can communicate. Devices from different manufacturers or different vendors communicating. Dai pasina ma-open standards. Dai pasina it's not interoperability. Dai vanhu vane ma-iPhone tisingakwanisi kucommunicate now. I know that for a fact. But since tine ma-standards, it means munhu ane itel, he has the ability yokufonera munhu ane iPhone because we work on the same standards. Ma-standards anoshandiswa for communication, they are the same. Meaning, iPhone chirekadhura sei, you still be able to communicate nemunhu ane mbudzi because the standards you are using, they are the same. So, ma-open standards, be very thankful for my open standards because they ensure and encourage yet not interoperability, allowing different vendors, different manufacturers to communicate, their devices to communicate. Then we have encouraging competition. It stems from having the same standards. My same standards wow, ana iPhone, for example, vave nema-products akati nake kupfuura vamwe, ndo panobva competition ipapo. Dai pasina ma-standards, probably dai tichiri kushandisa phone Nokia yekudhara zvidhina zvezve, because there will be no competition. Ndo vanenge vane monopoly over the market will be using that and only that. And I think competition relates to innovation as well, allowing my developers to develop zvinhu zviri innovative. Linking that to existing technologies, creating my new products, services without being locked into proprietary systems. My open standards allows us, how do I put this? You can build on previously established technologies. No one owns that because it's open. But I define an open standard that is available publicly, non-proprietary. So whatever is in that space is not for anyone. So inini kana ndinodotanga, I can start by using zvakatangwa kudhara izvozvo and build up on that. So my open standards encourages that. Dai pasina izvozvo, dai vamwe imwe technology tisingakwanisi kuita access kwairi because someone will say it's proprietary. You cannot use that. So I think my open standards, they're very important in communication because of that. Then standards organizations, they are vendor neutral, non-profit organizations. Question mark there. Established to develop and promote the concept of open standards. Vendor neutral, yes. Number 3, yes. Not so sure about number 2. But that's politics. Let's go. Internet standards. My internet standards, my standards, we have my types, we have my internet standards, internet society. You can become a members, if you didn't know, you can become a members of the Internet Society of Zimbabwe. It's very easy. So that you can see what does it do? It promotes the open development and evolution of the internet. Internet ikanzi yata down Zimbabwe yese ndo wanatanga complain yao. Internet Society of Zimbabwe, right? We have the IAB, responsible for management and development of the internet standards. IETF, develop, update, and maintain internet and TCP/IP technologies. We have IRTF, which focuses on long-term research related to internet and TCP/IP protocols. These are just organizations responsible for my standards and to discuss. My IP address, anobvp. We have my organizations like that one, IANA, Internet Assigned Numbers Authority, oversees and manages IP address allocation, domain name management, and protocol identifier for ICANN. That's where our IP addresses come from. My numbers, anotaura kuti number inowaridzi kudhara ndiani is IANA. So we have my organization is responsible for my standards that we use over the internet. Then we have some that we use for electronic end communications. For example, IEEE, we have EIA, TIA, ITU. As a student, and for the sake of the exam, you need to know at least what is the function of the standard organization. What is its responsibility of every organization and the present app. Reference models, almost done. The benefits of using a layered model. Right, Nabot define a model as a conceptual framework which makes my processes like networking very easy to explain. And my models that we have and are going to use tonight, the TCP/IP model and the OSI model. The TCP/IP, we've touched on that. 4 layers, application transport, internet, and network access. We also have the OSI model with 7 layers. Application, presentation, session, transport, network, data link, and the physical layer. Complex concepts such as how a network operates can be difficult to explain and understand. For this reason, a layered model is used. And some of the advantages, why, benefits, if I can say. Benefits of using layered models. Number 1, is not the same thing, Chiripa. Okay, benefits of using layered models. Assist in protocol design because protocols that operate at specific layers have defined information that they act upon and defined interface to the layers above and below. Let me just go through this and see. Foster competition because products from different vendors can work together. Prevent tech or capability changes in one layer from affecting other layers above and below. Provide a common language to describe network functions and capabilities. Why use my layered models? Why to define a network in layers? 1, breakdown of complex processes. That's 1. Networking as it is very complex. But if we manage to break it down, it might become less complex. So we break down complex processes with each layer having a specific function, therefore making the system much easier to understand. So per message size tambotaura kuti long message inonetsa kuheadline or it needs to be broken down. It's the same concept. Networking as a concept, very difficult. So we divide into my layers. Now my layers iwayo, we now focus on specific layers. Kuti layer rakati tunoita zvakati. Therefore, it becomes much easier to understand. You see, even career-wise, vamwe career yavo inoperera mu-application layer chete. Example, my developers, my software developers, software engineers, whatever that is. Career yavo inoperera mu-application layer. They develop, vanotambira varimo. Vamwe vachatambira layer number 3 mostly, network layer, kudzika kubva mu-transport, kudzika kuzasi kuno. Transport layer, layer number 3 network layer, munoitwa IP addressing, the data link, then the physical layer. Most of you ndo pamuchatambira ipapo if you're not going to be my developers. The reason why tichitoziva kuti ma-application layer ndo mune ma-software developers is because we've broken down a network into my layers, therefore simplifying it. So an example yandatopa career-wise, takutoziva kuti mulayer rakati ndo munoitwa zvakati, mulayer rakati ndo munoitwa zvakati. It also makes for easier troubleshooting. Isolating a problem. That's very important. Network ikaita problem pakatanga tikalose communication. How does using my layered models help? We know, I know, kana ndoda troubleshooter, I start looking at the physical layer. I know what the physical layer is. The physical layer consists of all the physical cabling, physical devices that we have. Kana ndiri troubleshooter, I start looking at that. So what do I look at? Ndinotarisa kuti makebho angu ese, okay, device rangu riri on here, for example. Macables ese anaita worn out, are correctly connected one, anaita worn out here, hapana short circuit here, zvese zviri proper here. I made the physical layer troubleshooting. If everything is proper, I then move, ndienda pane rimwe layer. Ndakutanga kutarisa NIC. NIC yangu iri okay here, because I'm in the data link layer. Right? So that framing yangu iriitika iri proper here. Kana zviri proper, I move to another layer. Up until I get pane problem. Without my layers iwayo, it becomes very difficult kuziva kuti ndotangira papi to solve a problem, which by definition is troubleshooting. So using my layered models is very important. And understanding with the layer rinofunctiona sei leads to understanding if you isolate a problem. Kuti ukaona problem, you can isolate kuti iyi problem haisi application layer. I think problem inogona iri network. So unotangirawo troubleshooting per network layer instead. All right. I see 1 minute. I think one more session will be enough to finish this one. You know the deal. Log in using the same